Welcome back, Stargazers. If you've ever gazed at the icy moons or distant dwarf planets, you've probably noticed something peculiar, those reddish patches that seem to appear everywhere. But what exactly are they? And how did they come to be? Join us as we uncover the fascinating secret of tholins, organic compounds that hold wonders we're just beginning to understand. First things first, what are tholins? Simply put, tholins are complex organic molecules made up of long repeating chains of subunits and functional groups, mainly hydrocarbons, nitriles, amines, and phenyls, meaning they consist of hydrogen, carbon, and nitrogen atoms. They form when carbon-rich compounds like methane or carbon dioxide, along with water or nitrogen, are bombarded by UV radiation from the sun or cosmic radiation from space. This breakdown leads to the creation of new compounds, which react and form reddish-brown residues on surfaces or aerosols in atmospheres. Tholins don't come in a single form, but exist in a spectrum, depending on the initial chemical constitution of the medium and its external conditions. The name tholin was coined by Sagan and his colleague Bishun Khare. It is derived from the Greek word Θολός, meaning muddy or cloudy, reflecting the murky appearance of the organic residues produced in their experiments. Sagan and Khare exposed compounds like methane, ethane, ammonia, and water to UV radiation or electrical discharge, simulating space conditions. Tholins have been observed or are believed to exist on various icy objects in the solar system, particularly those with methane-rich exteriors. Take Saturn's largest moon Titan, for example. Tholins form from the radiolysis of nitrogen and methane, which make up 97% and 2.7% of its dense atmosphere, respectively. They take the form of aerosols, solid particles suspended in the air, creating the thick orange haze. Sometimes these aerosols settle, covering parts of the icy crust. Another remarkable example is Pluto, whose surface tholins might have formed from the nitrogen and methane-rich surface and atmosphere. Charon's reddish North Pole might also contain tholins, formed from nitrogen-methane gases that escaped Pluto's atmosphere and traveled all the way to the orbiting moon. Moreover, the colored linear fractures on Europa's surface are believed to have formed from the irradiation of compounds that erupted with water from Jupiter's moon interior and flowed on the surface. Tholins are also detected or thought to exist on various other celestial objects, such as Kuiper belt objects like Arrokoth, centaurs, which are small objects orbiting the Sun between Jupiter and Neptune. And even comets like the famous 67P or Churyumov-Gerasimenko. Thinking of methane abundance, you might be imagining ice giants. And yes, they do contain substantial amounts of methane in their upper atmospheres. However, unlike the methane and water-rich environments we've discussed, these planets' atmospheres are primarily made of hydrogen and helium. As a result, instead of tholins, other forms of aerosols form from the irradiation of methane, creating hazy atmospheres that are not reddish. Surprisingly, tholins are speculated to play a crucial role in prebiotic chemistry, the kind of chemistry that could lead to life. They can scatter light and protect life from harmful UV radiation or serve as a food source for heterotrophic life, organisms that can't produce their own nutrients and must obtain them from their environment. This process likely predated autotrophic life, making tholins a valuable element in astrobiology. Tholins are thought to have existed on early Earth and may have played a role in the emergence of the first forms of life. However, after the Great Oxygenation Event 2.4 billion years ago, Earth's atmosphere became enriched with oxygen gas, which is highly reactive and breaks down complex organic compounds, preventing them from accumulating. In essence, tholins are complex organic molecules that form from the irradiation of carbon-rich compounds with nitrogen or water. They contribute to the iconic reddish colors found on many icy bodies and are thought to play a crucial role in astrobiology. So, what do you think? Were tholins a cornerstone in the emergence of life on our blue marble? Let me know in the comments below. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating journeys. Until next time, keep looking up at the wonders above.